Next presentation, Dr. Reinaldo Cook. Reinaldo, if you guys don't know, he was a master's and PhD student here at ONA until 2005, right? Yeah, 2008. He was a Dr. Artentel's student, and then he went to Oregon, worked as assistant associate professor there for 13 years, 9 years, yeah. Obviously, I don't remember. And then he joined Texas A&M. Good friend of mine. He was knew him since undergraduate school, and he's been part of my master's committee member. So great person, and I'm sure you guys are gonna enjoy his presentation. Okay.
Well, first of all, it's a pleasure to be back here at ONA. You know, I left in 2008. Yeah, it was December 2008 that I bought a brand new truck when I graduated, and Dr. Northington wasn't very happy about my decision, but screw him, right? So as soon as I got my PhD diploma, I bought a brand new truck, and then I had a pregnant wife, and I had 2 dogs, no, 3 dogs actually. One of them was actually born here at ONA, and then Austin remembers a dog when we picked it up. You know, the dog was about 6, 7 days old, and I think that the dog was lucky because all the siblings are probably, you know, didn't make it. But anyways, and then I just headed west to Oregon. My wife with my dogs. It's almost like a country song, right? And then I was in Burns, Oregon for 9 years. You guys know where Burns is? It's in the middle of nowhere, but it made national news because of the militia standoff with the feds back in 2016. So in 2017, I had a chance to come back to the South, move to Texas. It was a great move for us. It was actually almost coming back home, and I've been there for 4 years now. So, but it's always a pleasure to come back to Florida, to ONA, because this is home to me as well. A lot of the research that I do, it's on the cow-calf side, especially on nutrition of cows during gestation and how that impacts that offspring that's being generated in utero. And it kind of complements what Philipe does because he focuses on major ingredients or nutrients such as protein and energy. And I focus on other type of nutrients such as minerals and essential fatty acids. And this is what I'm going to talk about today with you guys. So as he explained, during gestation, the fetus depends completely on the cow for all the nutrients that the calf requires, right, to grow and to become a live calf, hopefully 9 months later. So the nutrition management of cows during the pregnancy, it's called fetal programming. How that nutrition impacts the development of that calf, it's the concept of fetal programming, okay? And usually what we try to do is to make sure that our cows are in good nutritional status throughout gestation. It's very common for producers across America, across the world, to, as soon as the cows are bred and the pregnancy is confirmed, and then you wean the calf, you just move those cows to the worst pasture on operation, or the farther pasture on operation, because her requirements are pretty low. Okay, she's not lactating anymore and she's already pregnant. But now we know that by decreasing the availability of nutrients to that cow during gestation has long-term impacts on that offspring. And a lot of this work came from the human research side. And I have 3 kids. You guys are going to see the 3 kids running around during lunchtime. And you can tell that by the energy, I did a good job in terms of planning my wife's nutrition during pregnancy. Just don't tell her that. And all this research that Philipe was talking about, and I'm going to cover today a little bit, came from the human side. So as my wife confirmed her first pregnancy, by the way, my first kid was conceived in Gainesville, Florida, and then was born in Oregon. But he tells everybody he was born in Florida, so he's proud of that. And we were planning on going to Gainesville on Saturday and spend the night to show my kid, you know, where he was conceived. Of course, I'm not going to explain how that happened, but he really wanted to see that. And because there's a tropical depression coming, we had to change the plans, and we're going to go home Saturday. But talking about tropical depressions, funny fact, my first year in Florida was 2004, and at that time we had 4 major storms in Florida. First one was Charlie, right? And I was living in the house back that way, and the house was built in the 40s, I believe. And I don't know how many hurricanes that house, went through, but you can tell it's probably one of the best buildings in all of Hardy County. But anyways, John Arthington, that was my boss at the time, and I was brand new here. I just arrived from Brazil, and he said, Reynaldo, there is a hurricane coming. We need to get out of here. Probably the safest place in the whole county was not only the house, but this brick building right here. Then he had a bright idea to go to Orlando. We know that the hurricane changed paths and actually hit Orlando, heads on. But my first hurricane was kind of all right. That's a pretty big deal. Then we had a second one. By the third one, he said, you know what? It's not that bad. Oh, I'll survive in that house. But throughout my 5 years in Florida, we had several major storms, and moved to Oregon. Got out of that because, of course, hurricanes don't make it into Oregon. But my first week in Texas again, then we had Hurricane Harvey. So hurricanes and tropical depressions and storms are part of my life, and it's always been. My first year in Texas, we had that Harvey storm, and then December we had a snowstorm. So that's Texas for you guys. But anyways, when my first kid was conceived, and I took my wife to the doctor, and then he had a few recommendations to her, right? The first one was that she had a normal body weight for human standards. So the doctor said, all right, for you to be healthy and to have a healthy baby, you need to gain about 30 to 35 pounds during pregnancy. Okay, you need to be on a steady rate of body weight gain. Of course, women don't like to hear that, but they do have to gain weight during pregnancy, especially in the second and third trimesters, because that's when the baby is really growing in terms of size. So the doctor recommended, and this is actually recommended by the NIH, that women gain about 4 pounds a month during the second and third trimester of gestation. And why 4 pounds a month? It's actually 2 or 3 pounds for the baby itself, for the pregnancy, and 1 pound for the mom. So the mom needs to gain a little bit of weight in terms of fat reserves to make sure that she is delivering all the nutrients possible to the baby. Because the female body, it's amazing. During pregnancy, the female is going to focus on the baby, try to push as much nutrients to the baby as possible, and whatever it's left, she keeps to herself. So if the mom is depositing some fat, okay, and that's for humans, that's for cattle, that's for all mammals, it means that the maximum amount of nutrients are being delivered to the baby during gestation. So the 4 pounds are basically 3 pounds or 2.5 for the baby and 1 pound for the mom. In addition to that, the doctor also recommended some kinds of special supplements, and one of them was trace minerals from organic sources. And most of the women that I know, especially from my family, they took some multivitamins during pregnancy, especially from organic type of sources. And we know that there is a big effect of zinc and copper during pregnancy in terms of development of that fetus, nervous system, circulatory system, immune system, all the important systems for that calf development. In addition to that, and you can see an example here to the left, where this is a pregnancy multivitamin supplement that it's pretty common. If you go to Walgreens or CVS, it's there for you to purchase. Another type of supplement that was also recommended by the doctor to my wife was the use of omega-6 and omega-3 fatty acids. And you can see on the right an example of such supplement, for pregnant woman. And she took both of them, and she followed all the recommendations from the doctor, the 4 pounds a month during the second and third trimester. So she gained weight, and she took all those supplements as the doctor recommended. Now, the doctor's recommendation was based on science. Okay, he is not part of this company, or he didn't make that up. It was part of science that's been done on the human side for the last 30 years. and only maybe 40 years. And only the last 10 years, we in the cattle business are trying to adapt the science into our world, okay? And the results are very encouraging because we're trying to follow what was done successfully in humans and adapting that to cattle. So when we talk about the 4 pounds a month, especially during the second and third trimester, we can actually extrapolate that to cow body condition score, right? So if the cow is depositing fat, it's gaining body condition score, and body condition score is the best way for us to assess visually the degree of nutrient or reserves in that cow. So if you look to the left, this is a cow with a low body condition score between 4.5, depends on whoever it's doing the evaluation. And if you look to the right, it's a cow with high body condition score between 5.5 and 6. So we know that the threshold for good body condition score is about 5, and for you to give that cow a little bit more, a little bit of cushion in reserves, we target a body condition score 5.5 or 6 at calving, so she has enough nutrients after calving to lactate and become pregnant again as soon as possible. So we designed a very simple trial to really try to mirror what has been done in the human literature or human research. And we had 2 groups of cows, okay? Simple study, 2 groups of cows. You can see the green line is cows that were always in a good body condition score, but steady, okay? They gain a little bit, you know, start at 5.6 and they calved at 6, just a natural variation of the cow. And then we had cows that throughout gestation were below 5. So we had a high body condition score, but steady, always high, not gaining, high. Remember, the doctor suggested my wife to gain 4 pounds a day, being 3 pounds to the baby and 1 pound to herself. So she's gaining body condition score during gestation, and those cows are not. This is a natural variation. You see how it differs from the next treatment. So green line, it's a steady, high body condition score, good body condition score, but steady. And then the red line is a low body condition score, also steady. But then we had a group of cows that went from 4.5 to 5.5 or 6 during the first trimester, okay? Then maintain that body condition score high all the way to calving. And it's very expensive to feed cows to gain body condition score during the first trimester because she's lactating. It takes a lot of supplements, a lot of groceries to get them to gain 1 condition score or 1.5. We also had a second group that gained body condition score during the second trimester, okay, which is easier because she's not lactating anymore, she's dry, so it takes less supplement to get them to gain 1.5 body condition score. And then we had a third treatment where they gained during the last trimester, the third trimester, which is a little more difficult than the second trimester because the calf already requires some nutrients. So anyway, 5 treatments. The green line always high, the red line always low, and then we had 3 treatments going up. So basically what we're doing is we're shuffling nutrients into the cow and hoping that those nutrients are reaching the fetus, okay? And those cows calved, and then we follow those calves all the way to weaning. So this is a busy slide, and all I want you guys to look at is those numbers in the green box. So basically, all the data in this table shows that cows, they calved calves with the same birth weight, okay? They produce the same amount of milk, okay? It's a little high, I know, but this is Angus Hereford process. And of course, our way to estimate milk yield is not the best, so it might be a little inflated. But look at the weaning body weight of the calves, okay? And look at the high body condition score cows. You guys see the pointer? No. No, whatever. So if you look at the cows that were on the high body condition score, the weaned calves that were 550, those 7 to 8 month old calves. How do you do it? Put me on the screen here. There you go. See it? Okay. So those cows 552, and those cows 557. So keeping cows at a low body condition score throughout gestation, the red line, gave us the same calves as the cows in a high body condition score. Remember, they were steady, okay? So we were maintaining those cows in a low body condition score or high, but we're not providing extra nutrients to reach the fetus. So basically the cow, everything the cow was getting, she was shuffling or sending to that pregnancy. Consequently, they didn't gain a whole lot of body condition score as expected in this group or this group. Now, if we gave them those additional nutrients, okay, in the first trimester, then we saw a bump in calf weaning weight. Now, the max or the best bump was when we did that increase in body condition score during the second trimester and maintained that all the way to calving. So actually those cows, they weaned calves that were about 30 pounds heavier compared to all other groups. So when we completed this trial, we noted that the body condition score during gestation is key. Maintaining a high body condition score but steady doesn't make any difference. The goal here is to give them additional groceries during gestation, so she's actually sending as much as possible to the calf, okay? And then consequently, that gave us almost a 38-pound increase in weaning weights, which nowadays that can be about $60 per calf in terms of calf value. In terms of the cost of supplementation, that varies according to location, according to year, of course, but it basically it cost us about $25 to get cows to gain that body condition score during the second trimester and maintain that all the way to calving, okay? So it pays off. Consequently, the goal here is to get you guys to understand that, all right, that cow is in good shape, but the point is for the pregnancy to receive the maximum amount of nutrients possible, that cow needs to be depositing fat. If she's depositing fat, then it means that the maximum amount of nutrients are reaching the fetus. And for us to monitor if she's developing or depositing fat, she needs to be gaining some body condition score. So overall, in terms of the main findings of the study is that the gain body condition score is more effective if it's done during the second and third trimesters, not only because of the better results that we saw here in terms of weaning weights, but because of reduced costs as we are supplementing non-lactating cows, especially during the second trimester, okay? So it's very important to monitor and allow cows to gain body condition score during gestation, and of course, gain body condition score when feasible. And we do that through proper energy and protein nutrition throughout gestation. Is there a question? No? Okay. But also exploiting the natural variation in body condition score of the cows. If they calve at 5.5 or 6, they're going to drop body condition score, okay? If they calve at 5.5 and 6, they will lose 1 or 1.5 after calving as they start to lactate. So naturally, it doesn't matter what you do, they're going to drop down to 4.5. Okay, it happens. And it's okay to let them drop, because if they're dropping body condition score and you're maintaining a good nutritional program, it means that they're producing milk and caring for that calf. Now, when it comes time to get them to gain body condition score, again, such as the second trimester gestation, it gives you the window of opportunity to deliver those nutrients and get a calf growing in utero as best as you can. So exploit the natural variation of body condition score of cows throughout the year. They will lose body condition score after calving, but that gives us the chance of providing a proper supplementation program to get them on that positive body condition score change during gestation to yield the best results in terms of fetal programming. Now, once we take care of business in terms of overall nutrition and taking into account all these changes in body condition score that I talked about, we can take the next step and go into the fine-tuning type of nutrition. And one of them is trace minerals, as I mentioned in my first slide. There's a lot of work, as Philipe showed, on energy and protein supplementation to cows during gestation, focusing on body condition score, most of them, but not a whole lot is known about the impacts of minerals during gestation. And it's very common for folks or friends not to feed any minerals at all to pregnant cows. Now, zinc, cobalt, manganese, and copper, they're all very important for fetal development, especially copper and zinc, okay? Selenium is also very important, but we are not, is this a selenium deficient area? Yes? Okay, so selenium also fits into this rationale as well. Where we did this project, Oregon and Texas were not on a selenium deficient area, so selenium wasn't part of the conversation. But again, we can extrapolate all this discussion to selenium as well. Those minerals are essential for fetal growth and development in utero. And of course, as we know, we can order or buy those minerals as inorganic or organic source. Okay, and the one that I do a lot of research with is the amino acid amido complexes. As I mentioned, mineral supplementation, especially to cows during pregnancy, especially after they are dry. Okay, after you wean the calves, are many times overlooked by cattle producers and nutritionists, but not by the human side. Okay. Humans are not deficient in minerals. We have such a variety in ingredients that we can use for our diets that we're not deficient in minerals. So why did the doctor told my wife to take the mineral supplements? Because the research shown that that extra provision of minerals is good for the baby. So why not do the same with cows? So very simple trial. We got cows pregnant at the end of the second trimester gestation. And why the second trimester, Reinaldo? Well, part of this research was done in Oregon, and of course we use a lot of public grazing in the West. And from April to November, those cows are grazing, large pastures that belong to the government. And if you try to supplement anything on those pastures, you're feeding the neighbors' cows, you're feeding the elk, the bears, deer. So it doesn't really pay off to supplement cows as they are grazing those large pastures. But we bring them back home or to the home ranch in October, November, and then they calve in March. So we have the opportunity to feed special treatments to them during the second trimester. So I'm gonna skip through those slides real quick, but I just wanna show you guys that we had 3 treatments. No mineral supplementation as a negative control. Okay, there's no supplemental minerals here. We had an inorganic group, okay, just as a positive control. So using sulfate sources of copper, cobalt, manganese, and zinc. And then we had a third treatment with organic, and the sponsor of the study was Zimpro with their Vela 4 supplement. Even the control diet wasn't deficient in minerals. Okay, if you look at the requirements for pregnant cows, I mean, we think we know the requirements, right? But anyways, if you look at the requirements from the books, even the control diet was okay, especially in copper. So basically the inorganic and organic diets are providing double than what the cows need in terms of what we know in the same amounts, one being from organic, one being from inorganic. So basically 3 treatments, no minerals, minerals from inorganic, minerals from organic. And we only fed the cows during gestation. At calving, we stopped the treatments. Okay. So all the results from this research are not associated with deficiency, but actually with additional provision of minerals from inorganic or organic sources. So we did a lot of stuff on those cows, liver samples. The calves were born, we collected the placentas to look at the transfer of minerals through the buttons. And the calves were weaned at 7 months of age, went to a feedlot for growth and slaughter. We retained ownership on those calves, so we had that all the way to slaughter. And this table shows that the 3 treatments, and I want to point out that at calving, we had increased concentrations of cobalt, of copper, of zinc from the supplemented cows as expected. You know, some minerals were better on the organic, some minerals were better on the inorganic, but overall supplementation increased in the liver of those cows, as we know it happens. But I want to show you guys the data from the calves. As soon as the calf hit the ground, we did a liver biopsy on those calves to see how much of that maternal supplementation was reaching the calf. And we did see that, especially for copper, we had more copper in the liver of the calves from the organic cows, as well as in the placenta, compared to the inorganic, which was intermediate, and then the control, which was the lowest. So showing that by providing minerals, you're not only feeding the cow, you're also feeding those nutrients to the calf. And if you use an organic source, okay, it doesn't matter which organic source you use, but if the technology is right, you have better passage and transfer of those nutrients all the way to the calf. Okay. Zinc as well down here. Okay. So we wean those calves, and look at the differences in weaning weights. Okay. Birth weight was about the same, but then we gained about 26, right? 25 pounds of calf if you compare the inorganic versus control. Then we gain about 34, almost 53 pounds of calf comparing the organic versus the control. So feeding our cows minerals during gestation is very important. Okay, look at the differences in weaning weights of the calves. Calves need minerals to grow in utero, prepare all the systems in the body to be productive after the calf's born. Shows you guys how important it is to feed minerals during gestation. If you have the chance, go into an organic source if possible. We kept those calf, and this is the calf value at the time of the study, an increase in 32 pounds, an increase $32 per calf, then an increase in about $70 per calf. And then we kept those animals in the range for 45 days for preconditioning. The difference was still there. And then when we ran the economics on this study, the organic treatment increased weaning calf value by $70 compared with control, with an extra feeding cost of 3.1 per cow. That's it. That's how much you spend. The inorganic, about the same, $32 increase compared to control, with the extra feeding cost of $2 per cow throughout gestation. $2 per cow gave you $32 back at weaning time. If you went with organic, $3 to $70. Okay, that pays off. Okay, and but again, on this study, all the calves were sent to the feed yard. We don't have the data from this study on the heifers being developed as replacements. Now, at the feedlot, we didn't see a major difference in average daily gain, but we do see a drop in BRD on the calves from the organic group, showing that there's a potential for organic minerals to help with the development of the immune system of the calf during gestation. At the time of slaughter, you know, the organic calves were still heavier, inorganic in the middle, and control calves the lightest, and then hot carcass weight about the same. So the difference is that we found that weaning weight, it persisted all the way to slaughter. Okay, so if you're retaining ownership, you're getting more money on your calves if you do the mineral supplementation. Now, so what does this all mean? Overall, the organic treatment decreased BRD during the critical time of the feedlot, which is critical for those that retain ownership or feedlot producers. The greater weaning body weight of organic calves was maintained all the way to slaughter, resulting in heavier carcasses, and this shows an indication of potential programming effects of mineral nutrition of cows during gestation on that offspring growth and health. Philippe, if I need to stop you, let me know, okay? Now, we did a similar study 3 years ago in Texas, feeding only the inorganic and organic. We skipped the control treatment because we need to feed minerals, we know that. And then we focus on the heifers. And we didn't see a major increase in heifer weaning body weight, okay, only 10 pounds, which is actually, you know, not bad, but statistically wasn't different. So at weaning time, those heifers were about a little lighter than we wanted. But anyways, after weaning, you know, they were on a pretty good diet, gaining about 1.3 pounds a day. Their final body weight at the beginning of the breeding season was a little over 700 pounds. But when we look at the puberty attainment of those heifers, the heifers coming from the organic cows to reach puberty sooner, okay, at an earlier age and lighter body weight compared to the control heifers. Also showing that the minerals during gestation have an impact on the development of that heifer's reproductive system. Okay. So again, the potential programming effects of minerals, especially organic, on reproductive development of the replacement females. Now, changing gears a little bit, let's focus on the omega-6 and omega-3 fatty acids. The same rationale, okay? Now, let's target a different nutrient, omega-6 and omega-3, just like my wife took during gestation. So, second trimester, the same thing, the same reason, because, you know, first trimester, they're grazed in public lands. And then we fed those cows during the winter, either a control fat supplement, which is only from saturated fat, just palm oil, just so those diets were the same in terms of energy and protein. And then the experimental diet was including omega-6 and omega-3, a quarter pound each. So half a pound of supplemental fat, especially omega-3 and omega-6 fatty acids. So the diets were about the same TDN, same crude protein, same fatty acid content, okay? Just differing in the fatty acid profile, okay? One had no supplemental linoleic, EPA or DHA, which are omega-3, and the other one had supplemental linoleic, omega-3, being EPA and DHA. So calves were weaned at 7 months of age, send them to the feedlot, all the way to slaughter. This is the cow plasma fatty acid content, and if you feed more linoleic, guess what? There's more linoleic in the blood. If you feed more linolenic, guess what? There's more linolenic in the blood. So that makes sense. Just to show you that, whatever you're feeding the cow reaches the circulation, consequently reaches the calf, right? Now, we didn't see anything very exciting all the way to weaning. Okay, differently than the minerals, the calves receiving the omega-6 and omega-3, weaned calves that were the same body weight as the control cows. Now, when those calves reach or enter the feed yard, okay, and start receiving a high energy anabolic diet, we saw major differences in average daily gain, okay? 0.2 pounds a day during the growing period and about 0.25 or quarter pound a day on the finishing period. So at the end of the feedlot, okay, those animals from the cows receiving omega-3 and omega-6 were 35 pounds heavier because of that increased average daily gain. And also they graded better, okay? They graded better marbling in the carcass. And we know that one of those fatty acids helps with muscle development, which explains this, okay? Which is omega-6. Now, omega-3, in turn, helps with marbling. That's why we had an increase in marbling. So omega-6 helps with muscle growth, okay? Omega-3 helps with lipid deposition. Now, other scientists believe it's the other way around. It's just we don't know exactly what's going on. But one of them helps with muscle, the other one helps with lipid deposition. So when we got done with this trial, it was pretty good news in terms of us that enjoy doing research with fatty acids. But the offspring from the cows receiving omega-6 and omega-3 had increased body weight gain and intramuscular fat deposition when exposed to high energy feedlot diets, which led all the way to heavier carcasses and better marbling. Okay, again, potential programming effects of growth and carcass development when you feed essential fatty acids, meaning omega-3 and omega-6, to pregnant cows, which makes sense based on what we know on the human medicine or human research, right? Now, to better understand the differences between omega-6 and omega-3, as I mentioned, we believe now that omega-6 is the one responsible for the greater average daily gain and muscle development. We ran a study only with omega-6, taking omega-3 out of the picture, okay? And what we found, was we did the same design, okay, but again, only omega-6 at this time, no omega-3, and a control diet without the fat. Diets were the same in terms of a nutrient content, but of course, the omega-6 diet had more linoleic, which is the main omega-6 essential fatty acid. So same design, calves went to the feed yard, and on this table, I want to show you guys something we didn't do before. As soon as the calves hit the ground at birth, we collect a blood sample before the calves suck the cow. We did see that the calves from the cows supplemented with omega-6, they had more linoleic in the blood, showing passage of that omega-6 fatty acids during gestation from the mom to the calf. Had less linolenic, and linolenic is omega-3, which makes sense, okay, and increase all the omega-6 fatty acids. So feeding the cow helps feeding the calf. Now, one of the interesting results we saw in this study was the cows that received omega-6, they had better colostrum. And there's something that we don't know very well in beef cattle is the importance of colostrum on calves' lifelong health and productivity. We kind of know that on the dairy side, but it's really hard to do colostrum research with beef cattle. But the cows receiving omega-6, they produce better colostrum than the cows receiving the control diet. Consequently, 24 hours after birth, the calves from the omega-6 cows, they had more IgGs in their blood compared to the control calves, which makes sense because of the better colostrum, right? Now, we wean those calves about 7 months of age, no differences in calf weaning weights, statistically speaking. There was a 5-pound increase numerically, but not statistical. But again, send those animals to the feed yard, and this is the growing part, okay? This ties back to the colostrum quality and also the programming effects of omega-6 on the calf's immune system development during gestation. Overall incidence of BRD was 40% on the control calves and 28% on omega-6 calves. And for us that do a lot of feedlot research, BRD is critical for whatever we do in a feed yard. And for you guys that retain ownership, the same. Okay, we don't want calves getting sick because we know that impacts the productivity and also costs us a lot of money. Now, we had a numerical decrease on overall incidence of BRD. If you look at the graph, okay, usually BRD hits the first month, especially with newly weaned receiving calves. And then we can see that the omega-6, it's not CSS, so it should be omega-6. They had less incidence of BRD compared to the control ones. But more importantly than that, the calves from the omega-6 calves, they require less antibiotics to recover than the control calves. Okay, they're more efficient in terms of using that antibiotic to recover from the sickness compared to the control calves, showing that the omega-6 supplementation to calves not only prevented the incidence of BRD, but also gave the calf a better immune system to fight the disease after it's received a antibiotic treatment. Now, when we look into overall productivity in the feed yard, same thing. An increase in about 0.3 pounds a day in average daily gain from the omega-6. CSSO is the type of a supplement, calcium salts of soybean oil. It's rumen protected fat, which is our omega-6 source. So 0.3 pounds a day more in average daily gain in the feed yard. Consequently, the carcasses were about 60 pounds heavier from the calves born from cows receiving omega-6. Remember, we only fed the cows, not the calves. Okay. Hot carcass weight about 35 pounds heavier, and rebuy area, which we like, bigger too, showing a better muscle development of the calves born from the omega-6 supplemented cows, which suggests this programming effect during gestation. So to summarize the slides and apply this on commercial operations, okay, here in Texas, in Brazil, in Oregon, anywhere you are, make sure, and ties back to the human literature as well, make sure that your cows are in adequate body condition score throughout gestation, okay, and they calve about 5.5, maximum 6, otherwise it's too expensive and you have problems post-calving. Again, if they calf at 5.5 and 6, they will drop body condition score during lactation. It's gonna happen, okay? But that gives you the opportunity to feed them again after they wean the calf, and then you have that, what do you call that term that we use when we provide extra nutrients to animals? Flushing. So you flush those nutrients into those cows when they are needing those nutrients to grow that calf in utero, okay? So when you take care of body condition score, then you can take the next step, which is that fine tuning. And the fine tuning in this presentation came in the form of minerals, especially organic, as well as omega-6 and omega-3 fatty acids, and omega-6 being the one that's responsible, we believe, for that increase in muscle development of that calf when it hits the feedlot. Okay, so with that, if you don't do this first part, doesn't matter what you do later. Okay, if you don't maintain your cows in good body condition score, whatever you do in terms of fine tuning ain't gonna work. Take care of business first. Okay, the main topics here, and then they will respond with the fine tuning, the additional technology, if you take care of your homework, which is maintaining those cows in a decent, good body condition score throughout gestation. So I appreciate the time, and I guess we can answer questions.